Hello, pre-calc students. Today we are going to continue and finish up section 7.4, Systems of Nonlinear Equations in Two Variables. And we're going to look at solving problems today, which, yeah, that's some word problems. Woo! But first, we're going to do another example of elimination to show you something else that can happen that we didn't see yesterday. So you can see here I've got an equation. This is the equation of a parabola, and this is a circle. And what I'm going to do here is I'm going to try to eliminate this, like term that they actually have in common. I do not recommend using substitution here. It might be tempting because this one is already solved for y, and then you could plug this in right here, which can work, except you'll be squaring something that's squared. You'll have to square this binomial, and then you'll get an x to the fourth power. And I think we might want to avoid that just because using elimination to eliminate x squareds will keep it with a second degree polynomial to solve, which I think will be a little bit simpler. So here's what I'm going to do here. I'm going to get everything over to, or get the x squared over to the other side, and now it's the opposite. So you can see I didn't have to multiply by anything, I just had to subtract x squared from both sides of this equation. I then can add these together to get 0x squared, but then y squared plus y, those are not like terms, they cannot be combined, so it's just y squared plus y. And then here, 3 plus 9 is 12. And now this is a quadratic that I can solve. I get 12 over to the other side so that this quadratic is equal to 0. And then I factor it. Y plus 4 times y minus 3 gives me solutions for y of -4 and 3. So then I take those two solutions, -4 and 3, and I plug them into either one of these two equations for y and solve for x. So if y is -4, I'm going to plug that into that first equation, and I get -4 equals x squared plus 3. I subtract 3, and I get x squared is -7, and then I get x is plus or minus the square root of -7, which that's the square root of a negative. So I actually get like imaginary number. So it's plus or minus I times the square root of 7, which isn't actually a real number. So that's nowhere on the graph. So basically I can say, well, this actually doesn't give me any real solutions at all. I plug in my other answer for y and I get 3 equals x squared plus 3. So x squared is 0. That doesn't mean there's no answer. It's just x is 0. That's a number that x can be. Because the square root of 0 is just 0. So that means if y is 3, then x is 0. Make sure you put them in the right order, x first followed by y, and you get the answer 0, 3. And that's the only solution. So you can see here, this is a parabola and this is a circle. Is it possible for a parabola and a circle to only have exactly one point of intersection? And you can see here that I actually graph these two in Desmos, and you can see that they do indeed have one point of intersection right here at the point 0, 3. So that's the what the graph of these two equations looks like. All right, now let's move on to a word problem. It says you have 36 yards of fencing to build the pictured enclosure right there. Some of this fencing you'll notice is going to be used to build a divider through the middle of this rectangle. If you'd like to enclose 54 square yards, what are the dimensions of the enclosure? So for this situation, what I'm going to do is I'm going to write a system of equations. I'm going to write two equations, one for the amount of fencing that I have and one for the area that I'd like to enclose. So I'm going to start by labeling the dimensions of this rectangle x and y, and then you'll notice if you look at how much fencing you need to use to build this enclosure, this distance x here, I'll have one piece of fencing that's x units long there, and I'll have another x unit long piece of fencing right here. And then this length y, I will have one segment that is y units long here, another one through the middle, and then a third one along that edge. So all this fencing will be 2 x's and 3 y's. So that's how I write an equation for the amount of fence. I have 36 yards of fence, and 2 x's plus 3 y's equals 36. And then I'm going to write an equation for the area. To find the area of this rectangle, it's just length times width, so it's just x times y needs to equal 54. And now this one is a system of equations that we then need to solve, and this system's a little different. You'll notice there's not an x squared or a y squared. The weird thing about this one is there's an x times y, which is not a linear, equation. So the way we solve this is we have to use substitution. And what we have to do is we have to solve this second equation here for x or y. And I'm going to solve that equation for y by dividing both sides by x, and I get y equals 54 over x. I then take that and I plug it into this equation in place of y, which gives me that. I then need to solve this equation for x. So I'm first going to do 3 times 54 there to get 162. But now you'll notice this red equation here, you can ignore the green for a second, is I have a fraction here with an x on the bottom. So the way I'm going to deal with that is I'm going to multiply both sides of the equation by the common denominator to get rid of the fraction. So I multiply everything on both sides by x. When I do that, I need to distribute over here, and I get 2x squared. When I do this times x, it cancels with the x on the bottom, and I'm just left with 162. And then don't forget to also multiply the right side. I get 36x. And now you'll see I have a quadratic to solve. I subtract 36x to get it equal to 0. Everything's divisible by 2. That's a common factor, so I'm going to divide everything by 2 to make it easier. And now this, hopefully you can see, is easily factorable, because 9 times 9 is 81. And then, minus 9x, and another minus 9x is negative 18x in the middle there. So that gives me the solution 9, and that gives me the solution 9, so there's just the one solution, 9. So x is 9. I then take that, plug it into either one of these two original equations. I'm going to plug it into this one to solve for x, and that means that 9y is 54. 9 is x. Plug that in for x, and I get 9y is 54, so y is 6. So the dimensions are 9 yards by 6 yards. So 9 is x, so this longer side is 9, and these 3 shorter ones are 6 yards. All right, let's take a look at another word problem. This one says the product of two numbers is 84, and 5 times the first number decreased by 2 times the second number is 2. So basically, I'm going to write one equation for each one of those sentences. The product of two numbers means the result when you multiply the two numbers. So that gives me this equation right here, x times y is 84. Then 5 times the first number decreased by 2 times the second number is 2. So that's 5 times x, decreased by is minus, 2 times the second, that's 2y, is 2, equals 2. So 5x minus 2y equals 2. Now you can see this system is pretty similar to the previous one. I've got, a line here and then this x times y. So what I'm going to do is I'm going to solve this for y and get 84 over x, and I plug that in to this equation here. And then I'm going to solve this in a very similar way to the previous one. I multiply everything on both sides by x to get rid of the fraction. You can see there, that becomes 1, and I get this. I then subtract 2x from each side to get this. Now this time though, there is not a common factor, so I need to try to work on somehow solving this quadratic. At this point, you might get out your graphing calculator and use quad form like I did here to get the two solutions, or you can try to factor it. It does factor because 6 times 28 happens to be 168, and 5x is 5 times x, and if you FOIL this, you will get minus 2x in the middle, or you can use the quadratic formula or your calculator's quad form to get these two solutions, negative 28/5 and 6. Well, then I need to take those two solutions and plug them each into my original formula in place of x. To solve this one, I divide by negative 28/5 on both sides, and you can use your calculator to do that, and you get negative 15. Here you divide both sides by 6, and y is 14. So here are your two solutions. You've got your two numbers could be negative 28/5 and negative 15, or your two numbers could be 6 and 14. So that's it for today. Go ahead and give that homework a try and let me know if you have any questions.